whenever we talk about point of intersection, the first thing that we should always think about is solving them simultaneously. In this case, we can use the method of substitution. So when I do that, so I'm going to let us call this as equation 1 and this one as equation 2. I'm going to substitute this equation 1 and 2. So then I'll be getting something like kx minus 2 whole square is equals to 4x minus x square. Now, when I think about simplifying this by expanding it with an identity of a plus a minus b whole square, this is going to be a square minus 2 times a times b plus b square is equals to 4x minus x square. I'm going to take each and every terms to one side. So this minus x square goes to the other side. So it would be k square x square plus x square. And in this one, this is going to be minus 4kx and this one also when goes to the left hand side, so it's going to be minus 4x then plus 4 equals to 0. And now I'm going to factorize few things. So in this case, if I take this x square common out, I'll be left with k square plus 1. And in this one, if I take x common out, I'll be left with negative 4k, negative 4 times x and plus 4 equals to 0. So when I compare this one with a quadratic equation, so which goes something like ax square plus bx plus c equals to 0. So when we compare it, in place of a, we have this k square plus 1. And in place of b, we have this negative 4k, negative 4. And in place of c, we have this positive 4. Now, so what we need to understand this one is, so we are talking about this graph meets the curve. And when I say it meets the curve, they never said, okay, whether the graph, whether this straight line is going to intersect the curve at 2 points or at 1 point. So that is not given. So if I have a graph something like this and this curve, this straight line just meets it. So it could be with 1 point or it could be with 2 points, but it will definitely meet. So that means if you consider this as a quadratic equation with some k value, this quadratic equation will have 1 or 2 solutions. So whenever I have any quadratic equation with 1 or 2 solutions, my discriminant of that equation, so which is nothing but b square minus 4ac, will be greater than or equals to 0. And here when you substitute all these points here, so minus 4k minus 4 whole square minus 4 times a is nothing but k square plus 1 times c is also 4. This must be greater than or equals to 0. So we are just going to simplify this. So when we simplify this, a plus b whole square, this is going to be minus 4k whole square, then minus of 2 times minus 4k times 4. Then I will be having it. So when I expand this, so this is 4 times 4 is 16. So 16 minus k square would be minus 16k square, then minus 16. And here I have missed out something. So here it would be then positive 4 square, which is nothing but positive 16. This must be greater than or equals to 0. So in that case, when I further simplify this, this is how this one would look like. So negative 4k whole square is nothing but positive 16k square. Then this is going to be negative times negative would be positive. So positive 2 times 4 is 8 and 8 times 4 is 32. So it's going to be positive 32k, then plus 16 minus 16k square and minus 16. And this must be greater than or equals to 0. Minus 16 plus 16 will get cancelled out. Minus 16k square plus 16k square will get cancelled out. That will give us the final answer to be 32k should be greater than or equals to 0, which means k must be any value which is positive. So that means k could be any value which is greater than or equals to 0. At that time, I could say this graph would meet the curve. So this is the right answer for this sum.